It looks like it's possible that there might be a bunch of stuff that should be
Okay, it's time for us to start the payload session. The note well, same note well as in the previous session. The agenda bash for today. We have the payload status update. We have a presentation on the flexible FAQ and on Rtp payload format for HTTP adaptive streaming. Any comment on the agenda? Okay. The document status. There are no RFC published. We have the Rtp how to still in the RFC editor queue. The what? I don't remember why it's there. Colin, do you remember? Forgot to look at it.
Colin Perkins, yeah, it's blocked on bundle and all of that.
Okay.
It's part of that cluster.
Okay. I think that's why we don't see. That's why we don't see Christopher in this room, because he's blocking everything. We have in the ancillary payload is in the ISG processing. There are some comments and from security I saw, and they're addressing that. Other document, the MELP codec, it was ready for publication, but when I checked the needs, there were some needs, so I asked the authors to address them before we send it to publication. The VP9 has expired. Jonathan, any news about this one?
So yeah, Jonathan, that's VP9 is technically complete. I feel like there's a lot of explanatory text about VP9, which I was hoping my co-authors would write, and they didn't, because they're probably more equipped to do so than I am. Do we have any Google people here who could go hit them with a hammer or something? That'd be helpful, but I think Harold has left, so I will try to nag them.
Okay, so you look at how to, because at least it's already expired.
I know. I got that notification.
Okay. There's a new Rtp payload format for VC2 high quality profile video. This is an Rtp payload format for the high quality profile of SMPTE standard ST2042-1, known as VC2. We got also an email on the list saying there's an implementation of this document already in some FPGA, and we need to reviews for these payloads and to do working group plus call. I'll ask the authors already to see if they can get some reviews from interested parties, and the only comment I got was the one about that's a really implementation of that already, and then we can do a working group plus call if I will check and verify that at least in terms of the way it is composed, it's according to the Rtp how to definition. Again, what's that?
Stefan Wenger, just someone refresh my memory. VC2 is direct? Is it direct? Do you know? Does anyone know what VC2 is? Yeah, I think it's this direct thing, right? Okay, thanks.
Okay. The current milestone. Okay, here we have 4 milestones marked in red. This one have not progressed for a long time, and we asked on the list if the authors have any intention to continue with this work. Otherwise, we want to remove these milestones. At least from the Bluetooth SBC, I got a response that says that they don't have any interest in pursuing this work. So we can remove it also based on that. But since we didn't get any other response on the list on that, we intend to do that. And I'd like also to ask you in the meeting if anyone has any objection to us removing those milestones, and of course removing those documents from they're expired anyhow, all these documents. So anyone object to removing these 4 documents? It's the EVBR G718 for proposed standard, the ISEC codec for proposed standard, which I think they don't care because they have now the Opus or whatever, the SBC, and there's the MPEG 2TS, which I don't think we have any. That was between, I talked with Ali about it. We don't have any motivation to continue with that. So if there are no objections, we'll just remove those milestones. So I don't see anyone running to the mic who's objecting. So I think we can do that. Ben will need to discuss how to remove those milestones, right? Just remove them. Okay. Okay. So we'll remove those milestones. The other milestones, we have the FEC, we have the VP9 video codec. We'll need to update the milestone date for that one. We have the MERP, which I hope we'll submit it for soon to publication. We're done with this. And we now have a milestone also for the VC2 high quality profile video. Okay, so this is the status. We can go now to the first presentation, which is about the FEC.
Okay, I'm Mo. We're going to be talking about version 03 of the flexible FEC scheme. Next slide, please. So we're going to go straight into what the major changes were. And there's really only 2 major changes. There was a decision at the last IETF in Berlin to remove the non-XOR codes, so the non-parity codes out of this draft. So there was Raptor and Reed-Solomon planned as alternate codes negotiated through SDP, but that since has been removed from the draft. That's the most major change. There's a lot of text removed for that. So the plan is to have new drafts that cover those different formats. So FlexFEC is not so flexible anymore. You have to have multiple payload types now if you want to use any of those other codes. The second major change was there was a retransmission format that was added one rev ago, and people commented that it was relatively inefficient compared to the RFC 4588 RTX. And so we looked at the packet format and tried to do some reduction of the fields that would not be necessary. So we got it down to 12 bytes. And I'll show in a minute what the differences were. But basically, it's now 3 words instead of 4 to 8 words for a full FEC header. But it's still not as efficient as 4588. The old retransmission header is only 2 bytes. There's a original sequence number, and that's it. Everything else is basically inherited from the RTP header. So there's a little bit of friction here that if we try to reduce the overhead too much, then we lose some of the benefits of flexible FEC. The point of flexible FEC is to have flexibility to do multiple things. You could cover multiple RTP streams. You can cover different header extensions on the on the flex spec packets versus the original packets. And you can have SSRCs that are different between the repair stream and the original stream. And all of those things would not be possible if we collapsed all the way down to the 4588 format. So if you look at all the stuff that it doesn't allow to be different, SSRC, the timestamp, the payload type, all of those things cannot be flexible under 4588. They have to be either derived from STP or they have to mirror exactly what was in the original stream. So we think we're maybe pretty close to the right trade-off. But if anybody has ideas that they'd like to bring it down even further, we're open to pushing the trade-off even more towards efficiency instead of flexibility. Okay, so next slide, please. So this is the new retransmission format. Now this is not the RTP header. The RTP header is before this. This is the actual FEC payload, which starts off with what is essentially an RTP header. This is the RTP header of the original packet. And so there's the change was we removed the length recovery, which doesn't make any sense. If you're protecting a single packet, you don't need the length recovery field anymore. So the length recovery was removed, and we moved the sequence number up into that spot. So now it looks a lot more like an old style RTP header. And the SSRC count field is removed, and its reserved bits are also removed. So you only end up with 3 words of overhead, 12 bytes of overhead, followed by the actual payload. And the payload here is actually the CSRC list and the extension headers, and then the real payload of the original packet. All right, next slide, please. Okay, there are also some minor changes. There was, in order to optimize the retransmission format, we had to swap the first 2 bits of the format, the R bit, the retransmission bit, versus the F bit, fixed bit. And so now the very first bit of the new format tells you whether or not it's a retransmission format or a FEC format. So it makes it easier for parsers. There's also a note now about the largest mask possible. So one of the FEC formats allows you to specify a mask of up to 108 bits. So you can protect this packet. This FEC packet can be protecting up to 108 source packets before it, and this mask tells you which of those packets it's protecting. And there's an extension bit as the mask grows from 16 bits to 32 bits to 64 bits. There's an extension bit on each one of those to let it grow. And obviously you don't need the extension bit on the very last 64-bit version of the mask if we don't ever plan to have any future extensions. If we don't ever plan to let it grow bigger than that, we can just remove that K bit and have one more sequence number that you could cover. So that was we just added as editors. No, we didn't actually remove it. But if anyone has a strong opinion of it, let us know. If not, we'll probably just go ahead and do that. Remove the note and then remove the bit, unless anyone objects to it. And there's a lot of editorial cleanup in a lot of the other sections. Next slide, please. This is the new format for.
Go back.
Sorry, go ahead.
Jonathan, yeah, I think I'd be inclined to say, a future extension would have to be something that you would, negotiate as a different payload type parameter or something. So you can't just. I don't see how any way that you could silently, backward compatible.
Well, remember the goal of this originally. The goal of FlexSpec originally was to have flexibility, so you didn't have to declare a bunch of new formats. It was so you could, we'd originally wanted to be able to add code points for Reed Solomon and Raptor that wouldn't require new payload types, and you could just, switch them in directly. Now they're going to have to go in separate drafts, but we still may be able to have a way to, figure out an extensibility mechanism to not require a bunch of new payload types for those things either. So the goal is if we ever wanted a mask bigger than what's currently defined, there may be a future draft that extends it. But yanking out the bit now, would close the door on that. Honestly, we don't see a need really to protect more than 100 or so packets in the past. That's already a pretty large window. you'd have to have a pretty high rate video stream to make protecting more than 100 previous packets, viable. So I'm sorry, one forward, please.
Colin Perkins, just on the previous, I mean, people are using RTP for some very high rate video streams. So have you talked to them and just make sure that they're not interested in this?
Yeah, that's a good point. There are the uncompressed, the SMPTE.
Yeah, I mean, there's a bunch of people doing that commercially nowadays.
Yeah. Yeah, I'll make a note to ask them about what they feel about FEC. A lot of those formats are for basically wired Ethernet kind of applications where they might not be employing FEC or expect any loss, but I'll ask around and see what. It's also worth noting that if you do have a need for enormous windows, there is, in the current spec, there is a facility for up to 64K windows. If you don't use the mask, if you use the row and column, you can have up to 256 rows and 256 columns. So you can have up to a 64K window of packets that you're protecting. And that's if you have a very regular fixed pattern, and large video like that would have a very regular fixed pattern. The mask is more for flexible video encodings where you only want to protect certain packets because some of them may be disposable. So you had a more pretty complicated video frame structure with disposable frames and less important frames and things like that. So you're only affecting some of them. That's what the mask is used for. And it's hard to see that growing much more than 100 packets in the past. Forward one slide. You're going backward or forward?
Forward.
There must be an error here because.
Sorry.
Yeah. Okay. Yeah, there we go. Yeah. So this is the new format for the full mask. When you're using FEC with the full mask, the largest possible mask, you see here. We're talking about removing that red K bit at the end to give you 109 packets instead of 108 packets of protection. We'll go ahead and do that unless there's anybody that objects. And we already swapped the first two bits so that the very first bit tells you whether or not it's a retransmission format or a FEC format. All right, next slide. So the only open issues, removing that K bit, I think we'll go ahead and just do that unless anybody objects. We'll give it a few days on the list to make sure nobody has an issue with it. And then the second major thing is I'd like to hear, nobody from the Chrome team, I don't think is here, but they're the ones that originally objected to having the retransmission format be inefficient. I think everybody supported having the retransmission format as an optional thing built into FlexFEC, so you don't have to negotiate RTX separately. So there's support for having retransmission, but nobody liked that it was so inefficient that you're eating, it was before it was like 20 or 30 something bytes. Now we're down to 12. The question is, do we really need to be more efficient than that? Are there people that want to use this for audio, where the whole audio payload is only 20 or 30 bytes, and 12 makes a big difference? So I'd like to hear from anyone that has an opinion on that, and I'm going to go ask directly to the Chrome team what their position is on the current size.
Lex, I mean, I would argue that we're not obsoleting 4588, right? So
no, we're not obsoleting.
If people want to use 4588, they still can.
We want to practically obsolete it.
What?
We want to obsolete it through.
Yeah, I know, but the point
through
is
de facto, not standards action.
It's overhead. 4588 is still there with all its headaches. So.
Yeah.
And sorry, Bernard Aboba says, I do think there is an application to audio since FlexFEC is better than Opus's internal FEC, for example.
Yeah, Opus's internal FEC is good for the low rate voice band streams, but if you're at the SUP layer, you're going to need higher level FEC. You're going to need outside FEC for that. So if you're using Opus for music streaming or something, you probably want something like FlexFEC. Just for voice, it's probably just as good to use in-band, Opus in-band. But okay, so we'll probably float a few ideas for optimizing the retransmission format on the list and see if anybody has an opinion either way. And again, like I said, the trade-off is basically flexibility for efficiency. as we try to squeeze it down, it's going to reduce some of the flexibility that the retransmission format has. You have to fix the, some fields to be negotiated in STP versus dynamic and things like that. There's more editorial work that needs to be done in some of the other sections. There's a lot of stuff that still needs to be cleaned up, especially in the registrations. And after that, I think no more other issues, and we'll be ready for last call. Any other comments?
Colin Perkins, just one editorial thing. You've got a bunch of fields named things like PX, M, CC, and so on, which are the same names as the fields in the RTP header. If there's any way of renaming them to something which doesn't match those, it might make it easier to follow.
Maybe lowercase, if we swapped them all to lowercase or something?
Yeah.
Okay. Yeah, that was a little confusing. Someone actually asked me, they saw the format and they were thinking it was the RTP header, and that's actually the payload. So you're right, it is a little confusing when you look at it. It looks directly like an RTP header. So we'll do some renaming there, and maybe we'll slap the full RTP header above it too, so that it's clear that there's both an RTP header and a effect payload header sandwiched together.
So just who read its document? Can you raise your hand? Who read the document?
This version or any version?
No, the current version. I mean, we want to go to working plus call, so I just want to favor, but because this was there was a lot of interest in the beginning for the document, so that's one. Okay. The what?
That's you. The interest is.
Okay. I hope that at least we'll do working plus call after this revision, but I hope that people will do a review for that.
And we're also working on implementations of this. So we're working to see if we can get into some beta versions of browsers to see how it works.
Okay, good. Thanks. Next one is the has.
All right, nice to meet you, everyone. I'm Hui, and Marvin is my English name. This draft talks about Rtp payload format for HTTP adaptive streaming. Actually, this is the second version of this draft. We presented this draft last time in Berlin. Since then, we have revised our idea and to make it clearer. So next, please. What we see is a little bit into the background. What we see is that paid video is becoming a revenue driver for operators. So you see that operators have already had this excellent video delivery platform, IPTV network, with a lot of features like forward, fast channel change, and forward error correction. All the features to ensure the quality of experience to the end users. So why not bridge the HTTP adaptive streaming technologies onto this managed IPTV network to bring more contents to the operators and to help them simplify the operations. So next, please. So progress since last meeting. We have proposed our architecture work in the broadband forum. Oh, sorry, a typo. In the broadband forum. And we have revised our idea. We have updated the architecture and use scenarios in the draft to reflect our new idea. And we have some updates to the fields in the payload format, which I will mention later. Next, please. So this is the proposed architecture. The key thing is the Multicast Gateway. It works kind of like a ODD client and posts these adaptive streams from the ODD server and convert each of the streams into a multicast group. So it also does it also fits the media segments into the Rtp packets. So from the multicast gateway, it passed down the multicast streams down maybe further into the home. And at home, we can use the traditional set-top box to receive the multicast stream, or we can deploy a MTU, which is multicast to unicast, acting as a RTP translator to convert the multicast to unicast to some device that does not support multicast directory. So the whole thing about this architecture is where do we think the trade-offs are made? We believe that that video that is live and of high quality will bring more profit to the operators. So the whole architecture the whole trade-offs are made for live video of high quality. For example, in 4K ultra high definition. So we want the multicast gateway to be as simple as possible. It may has a lot of processing to the video contents, but we need to ensure it to be low delay for the live content and to have high throughput for high resolution video. So that might require some updates to the receivers at home, to the clients. They may need to update their software to support these new RTP formats. Okay, next please. So why has over RTP, why a new format, new payload format? As I mentioned, we need the multicast gateway to be as simple as possible. Suppose the multicast gateway just retrieves the manifest files for example, the dash media presentation or the HLS, the manifest file for HLS. It only passes those manifest files and take out of the media segments and cuts and fits those media segments into RTP packets. That's a very simple processing on that. Just cut and just retrieve, cut and forward. We want to be like that simple. So the not using existing RTP payload formats, of course, presents some problems. First, the existing RTP payload formats may already be supported by clients. So we might need to update the clients. And existing RTP payload formats may require the multicast gateway to take a deep look into the payload format to pass the data of the media segments. So that is, I think, is too much in the processing. Okay, so next, please. So this is the RTP header. No change to the use of RTP header since last draft. We have the marker byte to indicate the last fragment of a media segment conventionally. We have the payload type. We have the sequence number incremented per RTP packet. What's tricky is about the field is a time step. Actually, we set the time step per media segment. So which I'll show you a diagram next slides. So this is an example of the packetization. I mean, if you look at the media segment 1, it has the time step of 1099234. So it's divided into 2 RTP packets. The 2 RTP packets will share the same time step, but each individual RTP packets will have distinct sequence number, and the sequence number will grow across multiple RTP packets, like that's in those packets for the second segment. All right. So next, please. This is the Rtp payload format, what we proposed. So we have the fragment bits URL are like in the last draft. What have been changed is we added an offset field in the payload format to help the client to relate the fragment to the media segment. And we have removed the type field. There used to be a type field to indicate whether this is a manifest file or initial segments of this of the hash of dash or HLS. But we don't think we don't want to multiplex those kind of information into the one stream. So we leave out those manifest initial information for the architecture to address. So we just so this format is just for the media segments extracted in the hash stream. All right. So next stream. Next, please. And the last thing is the fragmentation considerations. We need to fit. Okay.
Mosin, just one slide back. Question on this. So you said you removed the multiplexing of some things. You removed the multiplexing of the meta information of the container, but the media segments themselves are still multiplexed, audio, video, subtitle, whatever tracks the container had multiplexed together in each media segment, right?
Right.
Okay.
Okay.
And if it's
because we think the manifest files or on the initial information, they need more reliable means to reliable methods to deliver. Okay. So we don't want to.
And just curious, in your overall architecture, is anything actually going to terminate this RTP and render it, or all of these boxes that are terminating this RTP are going to forward it anyway as something else, not as multiplexed audio video over RTP?
I think it can either render it if the device has the capability, or it can forward it to to end devices, like to your phone or.
So the question is, what is the payload inside the RTP packet? What is the payload? It's not video and audio. It's dash or it's dash format or. Packet.
It's in dash format or in HLS.
It's a segment, right? It's a
segment.
Yeah.
It's a segment multiplexed. Who knows what? Just a bunch of tracks. Maybe audio, maybe video, maybe subtitle, maybe JavaScript. Just arbitrarily.
It relies on the clients to.
Right. So where I was going was, if you don't expect receivers of this RTP data to be the ones that actually render the media, they're just going to forward it along to something else. Then why even bother with RTP? Why not just multicast this, directly as the segment, over anything, over straight UDP or something? What does RTP add to the mix here if the receiver of that is not actually going to render it or time sync it or anything like that?
Okay.
We
use some of the RTP header, some of the fields in the RTP feeder header. In RTP header, we need that.
I mean, RTP is a little bit more than an end-to-end protocol. You can do FAC, you can do retransmission, you can use the whole infrastructure of all of our little support thingies with this thing.
Yeah.
I'm not sure whether it's a good idea, but RTP is there for a reason, and the reason is not only that to provide multiplexing of different payload types. Yeah, it's.
That's right. Okay.
Colin Perkins, yeah, I agree. The reason for using RTP here is that you'd want to render it, and you'd use the timing information.
Right. Okay. So the fragmentation. Okay. We have two ways for fragmentation. One is quite straightforward. We can just cut the media segments without concern too much about what's inside. We just cut it then to fit into the RTP packets. So, but this way, it's less resilient to packet loss, because one loss of this fragment could lead to the whole media segment undecodable. Maybe we can let the multicast gateway to do it in a more intelligent way. There are several ways to do it. If the media format in the hash segment is very simple, maybe has a fixed length, we can cut it just we can cut it by offset. So it's a quite simple operation. Or the media presentation, the manifest files can provide some hints where the next point is. So the multicast gateway can cut the media segments can repack the media segments into smaller pieces to make each individual pieces decodable. So this in this way, it may require more processing for the multicast gateway. Maybe more configurations for the multicast gateway. But the good thing is it's more resilient for the more resilient to the packet loss. Okay, so this is trade-off to be made between the balance is to balance the packet loss and the complexity in the multicast gateway, which needs to take care of when we implement this. All right. So next slide. Next, please. Next, please. So any comments, or just we'd like to know if you have any comments or suggestions, or if this idea is good enough to call for the WG adoption. Yeah.
So first of all, did anybody read the document, the draft? Okay. So so this is a payload format. So the question is, I would like to ask for adoption. This is a working group document for the Rtp payload format, based on also that this being done in also the work for the architecture, and the solution is done in another body, not in the IETF. So eventually they will need some payload format to describe it as a solution. So the question is, is there who would like to, who's for adopting this as a working group, as to work on this payload as the payload working group? Yes, Ben.
Ben Campbell. I didn't see behind me on the number of raised hands, but I gather from the unhappy noises that it wasn't very many. Are you ready to make that call, or would you like to try to encourage people
I'll
to take
try
the time
also.
to read it?
I'll try also on the list. I'll ask also on the list, but the first one I'll get here. But we won't take a decision only on what's here. I just want to see what's here, and I'll also go to the list and ask for people to read and to provide the view about adopting this as a milestone for the working group.
So how many hands did you see?
I saw 4, I think.
Oh, okay, that's more than I thought.
Hmm?
So
okay, so we'll go to the list. Like I saw that's what I saw 4 hands raised when I asked the question, and we'll go to the list to ask it before adopting this as a working group. Oh, okay.
okay, thanks.
Yes.
Mosinati, one final question. I know there's multiple variants of different OTT containers. Do you plan to support all of them? Do you plan to support all variants of dash segments, the HLS segments, or anything like that?
All right. Actually, we intend to support the major OTT technologies, dash, HRS. What we see is the convergence in the HTTP adaptive streaming technologies. Maybe I think dash will be the future open standard for all, but we can't neglect HRS.
Stefan Wenger, more, I don't understand the question, because basically what they are packetizing is a sea of bits, right? It doesn't really matter what those bits are, right?
No, but I haven't read the doc, so I don't know. But I assume that you do some parsing of the container format and then specifying how that extraction goes into the RTP, right? You're extracting at least timestamps,
Right.
and you're
right.
trying to inspect boundaries,
That-
decodable boundaries in the segments.
Th-
Right? So
That's
you do some
only
parsing
about
of
the
formats.
manifest files.
Yeah, but even the manifests are different between the container
Right.
files.
But
my
that's
main
supposed
question is-
easier to support
My main-
multiple
Yeah,
multiple file.
My main
manifest
question was
files.
whether or not you intend to support all of the major OTT streaming formats, and I think the answer was yes. So that's encouraging. I think that's a good approach.
Yes.
Tim Terry
thanks.
from Mozilla. If I understood correctly, there is one timestamp per entire dash media segment. So it is not parsing the container to pull out the timestamps for individual frames inside one of those segments. And so you can get that from the manifest file without looking in the container at all.
Okay.
Okay, thanks.
Thanks. And I think this is the last presentation for Payload. So we'll see you at the next IETF meeting. Where's the blue sheets, or if someone didn't sign, so please do that. Thank you.
Where's here? Okay.